Alright, testing. Alright, we're recording. Alright, skipping ahead to Training Circular 9237, Chapter 13, Destructive Non-Destructive Testing. Section 1, Performance Testing. General. To ensure the satisfactory performance of the welding structures and the quality of welds must be determined with the adequate testing procedure. Therefore, the proof of the test under the condition same with the more severe with the encounter of the welded structures in the field, the test revealed the weak of the defective section that can be corrected before the material is released for the use in the field. Thus, the test also determined the proper welding design and the ordnance of the equipment and the forestall of the injury and inconvenience of the personnel and untimely failure in the material. 13.2. Testing of the material, military material. Weapons of the proof, the test of firing with a covering with extra heavy charge of the determine the safety of the welded piece. Automotive material can be tested at high speed over the rough ground to determine the roadside. Welded armor, plate with other heavy structural matter that can be tested in gunfire with rejection with various calibers determined with the strength of under shock. Other similar materials used with the check of the performance complex structure of the house because of the material consists of several types of welded metals weldment of the various filler metal with successful operation. The entire structure of the weld must be withstand with the particular weld for which the design for the reason number of physical tests of the be divided to determine the strength of the characteristics of the welds to be used in the structure. 13.3. Field inspection weld equipment repaired by welding. General. The definite procedure for the testing of welding is not set up for the parts of the normal routine and ordered until the units operating within the field condition. If the facility are available, the same physical testing method may be instituted in general. However, the item welded may be subject to thorough visual examination by qualified inspector for the to be satisfactory. Thus, is returned with the youth of the Army and the service. Inspection procedure. The finished weld they should be inspected with the undercut overlap surface of the jacket for the cracks, other defects, also the degree of the penetration, side wall fusion, of the reinforcement, side of the position of the weld is an important factor for the determination as to whether the weld job should be accepted or rejected because of the reflective of the quality of qualified of the weld. Destructive types of experimental tests, welds. The conservative circumstances require the use of the new novel welding procedure for the new welding material for the unfamiliar apparatus welding operator. Lack experience in either use, inadvisable to make the experimental weld with the scrap and unsalvageable material of the welds with the welding material that may be subject to the destructive staff that require the development and proceed with familiarity with equipment can be attained in this manner. With a performance test, when the material has repaired with the standard welding procedure, the visual inspection should be sufficient for the determining the efficiency of the weld power with the repair of the item, with the return of the use of the arm, surface of the item should be the subject of the practical test as necessary to prove the ability with the stand with the train with the stress of the normal surface. If this will involve the towing of the driving the mobile equipment over the train that isn't normally expected with the transverse of firing artillery pieces to ensure that they will repair and not break down under the force of the recoil. In the most cases, the item can be replaced with the surface with an instruction with the using personnel to make one or more thorough inspection of the items that have the surface within a short time of the report with the signing of the possible failure, satisfactory, or unsatisfactory performance. Defective to repair parts, the case in this way, but it can be detected for serious trouble results. Section 2, Visual Inspection Correction. Incomplete penetration. For the term is described with the failure of the filler metal with the basin view, with the cab, with the root, with the joint, with the bridge, with the curring, with the groove weld, with the deposit metal, base metal not view, with the root of the joint, frequently called for the incomplete penetration for the joint design with not suitable for with the welding, proper condition with the construction of the groove with the weld with the one side only, and the complete penetration is likely to result with the following conditions. The root base dimension is too weak enough of the root opening, and adequate with the root opening is too small, with the included V and groove it is too small, the electrode is too large, the rate of the travel is too high, with the welding current is too low. Lack of fusion. Your lack of fusion of the failure with the welding process with the view that together all layers with the weld, with the welded metal, with the base metal, with the welded metal just rolls over the plate with the surface of the general review, the overlap of the lack of fusion is called for the following condition. Failure to raise with the melting point with the base metal with the previously deposited with the welded material. Improper deflection failed with the dissolve of the oxide, other form material from the surface of the deposited metal. Fuse, dirty place, surface improper electrocyte, the type of the wrong and corrective adjustment. Undercutting. Undercutting is the burning with the base metal with the toe with the weld with the undercutting may be called for the following conditions. Current adjusting of the too high with the arc gap with the too long with the failure of the fill with the carrier with the complete with the weld metal. Slag inclusion is elongated with the globular pocket of the metal oxide over the solid compound with the produce of the porosity of the welded metal with the arc welding. Slag inclusion generally made with electrode coating metal material with the flux in the multi-layer welding operation. Failure to remove the slag between the layer causes slag inclusion. Most slag inclusion can be prevented without improving the groove of the welded property before each of the bead deposits. Removing all the slag, making sure all the slag rises from the surface of the welded pool. taking care of avoiding and leaving any contours with the difficulty to penetrate fully in with the arc. Porosity. Porosity of the presence of the pocket that do not contain any solid material with the difference with the slag inclusion with a pocket that contains gas than other than solid. The gas forming with the voids of the derived from gas relief of the cooling weld because of the reduced volatility of the temperature drop of the gas form with the chemical reaction in weld. Porosity is prevented by avoiding overheating with the undercutting of the welding too high of the current setting and too long of an arc. Gas welding. Welding should be consistent with the width throughout the two edges of the through with a straight parallel line. The phase of the weld should be slightly convex with the reinforcement, not more than 1/60 inch above the display of the surface of the convexity, with it even along with the entire length of the weld. It should not be high in one place and low in another. The face of the weld shall have the fine, evenly spaced ripple with the should with the excessive span of the display. Scale pitting on the edge of the weld should be free with the undercut and overlap of the top should be blended together. It is difficult to determine where they have been taken place. With the query, or at the end of the weld should be filled with a slow show, no porosity of the holes or cracks. If the joint with the butt joint, check for the back side with a complete penetration through the void of the joint. Slightly beef that should be formed on the back side. With the root penetration with the fusion of the lap and the T-joints, check for the prodding of the pressure for the upper plate with the bottom bit double with the weld with the top penetrating with the root. The plate will crack and open at the joint with the beginning bent with the breaks. Observe the extent of the penetration fusion of the root with a problem with lagging in the fusion and penetration. 310. Gas metal arc welding with solid cord wire. Lack of the penetration as a result of a little of two heat with an input with the welded area corrected. That can be corrected by increasing the wire feed speed with reducing stick-out distance, reducing the speed of the travel to use the proper welding techniques. Excessive penetration usually can cover the burn through with the result of too much heat with the welded area with the corrected by reducing wire speed with increasing the speed of the travel to making sure the root opening of the root face are correct, increasing the stick-out of the distance during the welding and the welding gun. Whiskers are short length of electrode wire string with the welding of the root side of the joint with the pushing of the electrode of the wire past the leading edge of the welded pool. The whiskers can be prevented by reducing wire feed speed and speed travel to increase the stick out distance weaving of the gun. Voids. Voids are sometimes referred to as wagon tracks because of their resemblance with the rust of the dirt of the road that may be continued both sides of the weld at the deposit of the found with the multiple blast weld. The voids can be prevented by avoiding large contoured crown undercut with making sure that all the edges are filled in and succeeding passing with a slightly higher arc voltage increasing the travel speed. Lack of fusion also referred to as a cold lap over as a result of the improper torque channel. Low heat with a high speed travel is important when the arc can direct the leading edge of the puddle to prevent this defect with give the careful consideration of following. Directly arcs over the coverage all areas of all of the joint. The arc not puddle, but should not do the fusion. Keep up with the electrode leading with the edge of the puddle, reduce the side of the puddle with the necessary. They reduce either the travel speed, fire speed, or check the current values carefully. Porosity. The more common defect of the weld that produced in any of the welding process of the porosity that exists with the face of the weld readily detected, but porosity must be the weld below the surface of the determined by the X-ray or other lead testing method to cover the more porosity. Contaminant of the atmosphere, other material, the oil, dirt, and rust, and paint the chain of the physical qualities of the filler wire due to the excessive current, entrapment of gas involved during the welding, metal solidification, loss of the shield gas because of too fast to travel. Shield gas flow rate too low, not providing full protection. Shield gas flow too high, drawing air into the arc area with the wrong type of the shielding being used. The gas shield blown away by wind and draft. And 10-9 defects of the gas system. 10 improper welding techniques, excessive stick out, improper torch angle, them too fast of the removal of the gun and the shielding end of the weld. Alright, spatter. Spatter is made of fine particles made with a plate with a surface joining with the welded area that usually come with a high current, long arc with irregularity, unstable arc with improper shielding gas and clogged nile. Irregular welded shake. Irregular welded include those too high with the too narrow, but those have excessive convex concave surface. For those who they have the coarse irregular ripples with the characteristics maybe to do with the poor torch manipulation. Speed travel is too slow. Current is too high with the low improper arc voltage, improper stick out, improper shielding gas. Undercutting. Undercutting is a cut away with the base material along with the edge of the weld with the main present with the cover of the pass of the weld to be in with the multi-path with the condition usually with the result with the high current with the high voltage excessive with the travel speed, low wire feed speed with the poor technique with the improper the gun gas shield with the wrong filler wire with the correct undercutting more with the move of the gun side to side of the joint. Hesitate at each side before returning to the opposite side. Gas metal arc welding with flux cord wire. Burn through. Burn through may be caused by the following. Current too high with excessive gap between the plates. Travel too slow with a bevel angle too large. Nose too small. Wire size too small. Insufficient melt down, hold down, and clamp the crown too high, too low. The crown weld may be incorrect due to the following. Current too high, low voltage too high, or low travel speed too high. Improper welding backing, improper spacing welding. welds with backing workpiece not level. Penetration too deep or too shallow. Incorrect penetration may cover the name of the following. Current too high with the low. The voltage too high, low. Improper gap between the plates. Improper wire supplies. Travel speed too slow or too fast. Porosity gas pocket defects may result in any of the following. Flux too shallow. Improper cleaning. Contaminated welding backing. Improper fade up of the welds. And manual backing. Insufficient penetration. Double weld. Reinforcement narrow. Steep slope. Pointed. Narrow. Pointed reinforcement may cover the flowing. The insufficient width of the flux. Voltage too low. F. Mountain range. Reinforcement. The reinforcement rag of the flexion was too deep. Undercutting of the baby cover. The following travel speed too high. Improper wires. Position fillet welding. Improper welding backing. Alright, voids incorrect. The weld deficiencies may be caused by any of the following: improper cooling and failure to preheat, improper fit up with the concave of the reinforcement fillet weld. Alright, let's read Section 3, Physical Testing. General, with the test of the travel, the section, of the develop, with the track, with the skill, of the welding operators, quality, with the weld, the metal, with the strength, with the weld, the joint, each for the type of the metal, you with an ordnance material. Some of the tests for the tensile strength, bending test for the destructive, and some of the tests of the assessments are low, with the fail, with the information cannot be gained with the other testing methods, such as the extra A and hydrostatic or not destructive. Acid test. Test you with the determine the silence of the weld, the acid attack for the reacts for the edge of the crown of the base of the weld, mount to the scope of the weld, the defect of the present of the action. Insinuate the boundaries between the base and the well of the metal within the span of the show of the side of the well, but the otherwise distinct. And the test usually performed on a cross section of the joint. Solution of the hydrochloric acid, nitric acid, ammonium sulfite, and iodine or potassium iodide, or commonly used with etching carbon and low alloy steel. Your guided bend test. Quality of the weld, of the medium of the face root of the weld, the joint, as well as the degree of the penetration fee for the base metal, with the determined means for the weld of the guided bend test. Of the test made with a jig, with a test specimen, machine with the weld, the plate thickness of the must be within the capacity of the bending jig, with the thickness specimen placed on across the supports of the die, which is the lower portion of the jig of the plunger of the operator above, with the hydraulic jack out of the device, cover the specimen, the force into, and ensure the shape of the die, with the fulfill the requirements of the test of the specimen may be bended 180 degrees, except the passable. No cracks greater than 1/8 of an inch in the dimension shown appear with the surface of the face bend with the jig of the face with the tension and outside of the bend. A figure 12-13A with the bend test made with the root on the weld tension on the outside of the bend. Figure B figure 13-2 with the guide bend test specimen also shown figure 13-3 with the page 13-10. All right. Your free bend test has to divide with the machine, measure for the ductility of the weld, with the deposit with the weld, join with the test specimen machine with the weld plate, with the weld located with the A figure 13-14. 13-4 with the ending corner lock lengthwise of the specimen round with the radius fanatic stand with the 1/10 of the thickness of the specimen, 2 marks with also with the lengthwise of the specimen, 2 scribe lines with the place and face 1/16 of an inch edge of the edge of the well with the distance between the line with a measure of the inch of the record as the initial distance x of the end of the test specimen or bent with a low the angle with about 30 degrees with the bending of the beginning approximately 1/3 of the length of each of the end. The well is located centrally to ensure that all of the bending in the curve of the well. The specimen initially is then placed in a machine carrying and exerting large compressive force bent until the crack greater than 1/16 of the length of the dimension appears in the face of the weld. No crack appears bending of the continuum until the specimen is 1/4 of an inch thick under the test device. The heavier plate will be tested and best bend jig with the device and other type of compression devices used when making the face free bend test. The advisable machine upper and lower contact plates, bending and equipment to prevent surface player welds to the end of the specimen. This will prevent the specimen from the slipping and snapping out of the test machine as it is bent. After bending the specimen to the point where the test is bent, with the conclude with the distance between the scribe line with the specimen with the measure for the recording with the distance, while with the finding of the percent elongation, subtraction of the initial and final distance divided with the initial distance multiplied by 100 with the usual requirement of capacity for the door types of minimal elongation with the 15% of the no cracks greater than 1/16 any dimension existing on the one face of the well. The free bend test is largely replaced with the guide bend test wherever the required with the testing equipment is available. The back bend test is used to determine the quality of the weld metal with the degree of the penetration from the root of the wire with the welded bent and butt joint. The specimens are similarly required with the free bend test except for the bent and with the root over the weld with the tension side with the outside of the specimen with the required with the 90 degree for the breaking apart without breaking apart with the test is being largely replaced by the guide bend test. Your nick break test has been divided for determining with the welded metal with the welded butt joint with the internal defect of the slag inclusion gas pipe with the poor fusion with the oxide with the burnt metal with the metal the tank with the welded butt joint either with the machining with the cutting of the oxyacetylene torch either with the edge of the weld with the joint with the story of the veins with the saw cutting torch through the center. These places thus prepared with a bridge of confidence two steel blocks of the instructs with a heavy hammer, and the sections of the weld become slots and fracture of the metal thus exposed. It was completely fused from the free of slag with inclusion. Size of any of the gas pockets must not be greater than 1/16 of an inch. If the any must be greater than the dimension number of the gas pocket, the pour per square inch should not exceed 6. Another brake test method is to determine the soundness of the fillet weld. The fillet weld brake test the force means of the press of the testing machine blows over the hammer applied with the apex of the V-shaped specimen of the fillet weld. The rupture of the surface of the fracture will then be examined for soundness. Our tensile strength test. The test is used to measure the strength of the weld of the joint of the portion of the weld machine located with the weld midway between the jaw of the testing of the machine with the width and the thickness of the testing measured or before testing area of the square inch is calculated by the multiply before the test area of the square inch is calculated multiplied by these two figures. The tensile test specimen with its mouth out of the machine with exerts enough pull on the piece to break the specimen. Testing machine may either be the stationary or portable type of the machine, with the portable type of the operating on a hydraulic principle capable of pulling as well as bending. Testing specimen shown figure 13.7 with the specimen being testing, and this machine loads in pounds registered in the gauge of the station. Any type of load applied with may be registered balancing beam. In either case, the load point breaking is recorded with the test speed specimen broken at a tensile strength are shown in figure 13.3, page 1310. Are the tensile strength which is defined as strength with the stress in pound with the squaring with the calculated with the dividing with the breaking load with the test speed of the original cross protection area with the specimen. The usual requirement for the tensile strength welded specimen shall not be less than 90% of the base metal of the tensile strength. With the transfer shear strength with the transfer with the longitudinal fillet weld to determine tensile strength with the test specimen with the width of the specimen with the measure for the inch of the specimen with the required with the tensile load with the maximum load with the pound with the determined shear strength with the welding in pounds per millimeter with the determined with the dividing the maximum load with the length of the fillet over the weld with the rupture with the shear strength with the pounds per square inch is obtained by dividing the shear strength in pounds per linear inch average throat dimension of the welding inch of the test specimen are made with when they are required or machined down to size. Hydrostatic test. The non-destructive view for the check of the quality of the weld of the clothes containing over the pressure vessel and the tank of the test usually consists of the filling of the vessel with water applying the pressure greater than the working pressure of the vessel. Sometimes large tanks are filled with boilable water, which will be no under pressure for the detect the possible leak of the defective weld. Any other method is to test oil, then steam them out the vessel and back, seeping of the oil behind the linear show of the visibility. Your magnetic particles test. This is the test inspecting method of one used on the welds of parts with the magnetic alloy with the shield with the applicable only with the ferritic material in which deposits with weld is ferritic material with a strong magnetic field with the set of the piece of the inspected means of high ampere electrical current leakage field will be set with the produced and discontinued with the intercept of the field and part of the local poles and produce leakage field with the poles attract with the whole magnetic particle with the placed in the surface for this purpose for the particular pound to produce surface indicate with the presence of the discontinuity defect and closed to the surface of the part. Are your X-ray tape. The radiographic test used for the method used for the reveal of the presence and nature of the internal defects well of the crack, slag, blowhole zones with the proper diffusion lacking. In practice, the X-ray tube placed on one side of the weld of the plate with the X-ray film and the specific sensitive emulsion on the other side. Develop the defect with the metal show up with the dark spots and bands which can be interpreted with the operator experience with an inspection method. Porosity, the defective root penetration disclosed in the X-ray inspection shown figures 13.8. Alright, 1322, gamma rays test. The radiographic inspection method is similar to the X-ray method described in the paragraph 13.8, except for the gamma rays that emanate with a capsule with the radium and the sulfate instead of the X-ray tube that pick up with a short wave of the lengths of the gamma rays. Penetration of the section, considerable thickness is a lot possible, but with the time of the required with exposure, any of the thickness of the metal is not much longer than those required with the X-ray because of the slower rate of the gamma rays are produced. X-ray testing is used most radiographic inspection, but gamma ray equipment has an advantage of being extremely portable. Alright, fluorescent penetration testing. Fluorescent penetration inspection, non-destructive type of method means of which with the cracks, with the pores, leak, with the other discontinuities can be located with a solid material, particularly with the use of locating with a surface defect with the magnetic material, aluminum, magnesium, synthetic steel, welds, locating and leaking all type of welds. The method makes a use of water washable, higher fluorescent material with exceptional penetration qualities. The material is applied with a cleaning dry surface of the metal, inspected with the brushing and wipe, spraying and dipping with excessive materials, remove the right, rinsing and whipping with a cleaning water soaked with a cloth with a sandblasting, wet and dry type of developer, then is applied, discontinued with the surface that has been properly cleaned with a tree with a penetrant with a rinse with a tree with a developer show brilliant fluorescent indications under black light. Are your hardness tests. General hardness defined as a ability to substance with a resistant indentation of a localized displacement. Hardness test usually applied is a non-destructive test, usually primary laboratory, not to any of the great extent of the field. With a hardness test, you have the means of the controlling of the properties of the material. The specific purpose of the desired hardness has been established with a particular application. The hardness test is used to determine the hardness of the welded metal. The careful testing of the welded joint with the hard areas with being isolated with the extent of the effect of the welding heat on the properties of the base metal determined. Your hardening test equipment, the file test, the simple method of determining with the comparative hardness of the file test performed with the running of the file under the manual pressure over the piece being tested. Information may be obtained whenever the metal tested is hardened or softer than the file, other than the materials having given the same with the treatment. Hardening testing machines, general. These are several types of hardening testing machine, but each of these are signal and functional design. Best lends itself particular field application with a machine with intent with however the more than one type of the machine can be used with a given metal hardness value obtained with a satisfactory correlate with a two-tip machine with obtained commonly with the laboratory test for metal hardness, the Brittle hardness test, and the Rockwell hardness test. The Brittle hardness test is the specimen mounted on an anvil machine and a load of 6,662 pounds is applied against the hardness or steel ball with the contact with the surface of the specimen being tapped with the steel ball is 4/100 of an inch and 4/10 of an inch diameter lobe with allow the remaining of 1/2 a minute with then relief the depth of the depression made above the ball of the specimen. Measure the resultant brittle number is obtained with the following formula. It should be noted that in order to facilitate the determination of the brittle hardness for the diameter of the depression, rather the depth of the actual measure for the charts of the brittle hardness numbers have been prepared with a range of impression of the diameter of the chart. These charts are commonly used to determine brittle numbers. Your Rockwell hardness tester for the principle of the Rockwell tester for the essential for the same of the brittle tester for the deferred for the brittle tester for the lesser lobe for the impressed for the smaller bone cone-shaped diamond. Depth of the indentation measure for the indicate with the dial attached for the machine with the hardness for the expression for the arbitrary with the figure for the called the Rockwell number to these prefix letter notation such as B and C indicate with the side of the ball with the U with the impressed lobe with the scale U with the test. 1225 Magnaflux test. General with the rapid non-destructive method for the locating defect with the near the surface of the seal with the magnetic alloy meaning with the corrective magnetism application ferromagnetic particles. Basic principle: all practical purpose of the magnetic flux and section may be linked with the use of the magnifying glass. Instead of using glass, however, the magnetic field with the ferromagnetic powders are employed with the method of the magnetic particle inspection based on using up to two principles. One, with the magnetic field with the produce of the piece of the metal with electrical current flow through and around it. Two, with the minute poles are set up with the surface of the metal with wedge over the magnetic field is broken and distorted. Whenever the ferromagnetic particle is brought with the vicinity of the magnetite with the part with the strongly attached with these poles with the held more firmly to then the rest of the surface of the part with the layer by forming a visible indication. Alright, 1326, your eddy current electromagnetic testing. General eddy current with electromagnetic testing of the non-destructive method based over the principle of electrical current which flow when any of the conductors submerged. Changing the magnetic field with the tube, the check weld of the magnetic with the non-magnetic material with the particular used in testing bar, fillet welds and pipes and tube. The frequency may vary from 50 Hz to 1 MHz, depending on the type of the thickness of the metal material current method. If the former pertains to the test whether the magnet permittable with the material with a factor affecting test result with the later test with the electrical conductivity is a factor involved. Non-destructive testing eddy current method has been involved with inducing electrical currents eddy of the four folculate currents of the test piece with the measuring of the change of the produced in these currents to discontinue with the other physical differences in the test piece. Since tests can be used not only for the detect discontinuities but also for the measure of the variation of the test measure piece to mention resistivity. Sense of resistivity is depending upon such properties for the chemical composition, purity and alloying, crystalline, hour orientation, heat treatment, hardness. These properties can also be determined indirectly with electromagnetic methods classified magno-inductive eddy current methods. Former pertinence testing magnetic permanent material factor affecting the test result later in testing electrical conductivity factor involved. C1 method of producing eddy curve of the test specimen is to make the specimen core of the alternating current induction coil. There are two ways of measuring change for the current magnitude distribution of the current of the first to measure for the resistance of the compound and impedance of the existing coil of the secondary test coil of the secondary to measure for the inductive component of the impedance existing on the secondary coil of the electrical equipment had developed measuring either the resistive and inductive impedance of components singly and both and simultaneously. Alright, eddy currents continue. Eddy currents are induced within the conducting testing specimen, alternating electromagnetic induction, transformer action. Eddy currents are electrical in nature and have all the properties associated with electrical current within generated eddy current for the test bead for the mouse behalf of the conductor for the brought into the field of the coil occurring alternating current. The coil may encircle within this part B form of the probe, but in this case within tubular shape that may be wound inside of the tube of the pipe. Eddy current of the metal specimen can also be set up to wound with the magnetic field of the probe of the original magnetic field of the impedance of exists exciting coil of the second coil coupled with the first of the close of the proximity of the specimen, the effect of the presence of the inducing eddy current of the second coil is often used with the nancy cause of the sensing of the picking up of the coil of the end of the path of the eddy current is asserted presenting with a discontinuity crackle of both divert the crowns of the eddy current of the man over the apparent impedance of the coil of the chain in the presence of the defect change of the measure for the U of the given indication of the defect differences of physical and chemical metallurgical structure, subsurface discontinuity, and may also be detected by both current fails fall offs with the depths. Alright, we're almost done here. Acoustic emission testing. Acoustic emission testing can currently be considered the supplementary of the non-destructive testing method that have been employed, however, during proof testing, recurring inspection, surfacing, and fabrication. Acoustic emission testing consists of the detection of acoustic signals producing plastic deformation, crack formation during loading. These signals are present in wide frequency spectrum along with the ambient noise from any other source of the transducer strategically placed on a structure and activated with arriving signals by suitable filtering method. Ambient noise if it's possible signal is notable reduced, and any source of the significant signals is applied with the triangulation arrival of these signals of different transducers. Your ferrite testing effects of ferrite content. Ferrite value. Fully authentic stainless steel welded deposits have a tendency to develop small fissures even under conditional minimal restraint. Small fissures tend to be located with a transverse weld fusion welded past the base metal with reheated with the near the melting point over the material, but subsequent welded passage cracks are clearly injurious effects. Materials of subsequent welded passage cracks are clearly injurious defects and can be tolerated. On the other hand, effective fissures weldment performance less clear since the microfissure quickly blurted on the very tough and static matrix. Fissure weld deposits have been performed satisfactorily on various surface severe conditions. However, the tendency to form fissures generally hand-in-hand tendency to large cracking is often desirable to avoid fissure-sensitive welds. The presence of a small fraction of the magnetic data of the ferrite phase is otherwise untested. Synthetic non-magnetic weld deposit influence of the prevention, centerline cracking, fissure amount of delta ferrite, as well as material largely controlling the balance of the welded metal composition between ferrite promoting elements of the chromium, silicon, molybdenum, cadmium, and most common the austenitic promoting elements nickel, magnesium, carbon, and nitrogen are most common. Excessive delta ferrite or can have the adverse effect of the metal properties. The greater the amount of delta ferrite, the larger the welded metal ductility toughness. Delta ferrite is often preferentially attacked with a few corrosive environments such as the Ura, extended to the exposure temperature range of 900 to 1700 degrees Fahrenheit. Ferrite tends to transform in part a brittle intermetallic compound that severely embrittles the weldment. And portable ferrite indicators are designed to on-site use ferrite contact weld deposit indicate with a percent ferrite may be bracketed between two values that provide sufficient control in the most applications where the minimum ferrite content and ferrite range is specified. And that was chapter 13.